Now let us go to what are equal sets. Equal means the two sets have to be equal to each other in the sense that the number of elements in both the sets should be equal to each other, and the elements which are present in both the sets should be the same. The order of the elements does not matter. Only we have to see that each and every element in one set should be the same as the element in the other set. Now let us consider two sets, set A and set B. Let us see how we define equal sets. Two sets A and B are said to be equal if every element of set A is in set B and every element of set B is in set A. So if all the elements of one set are in the other set, as well as if all the elements of the second set are in the first set, then those two sets have to be equal. So when we say that the two sets are equal, set A and set B are equal sets, then how do we write it symbolically? That is using symbols A equal to B, because sets are represented by capital letters. So set A equal to set B. When we read it just as A equal to B, but here we are talking about sets, so therefore this is set A is equal to set B. Let us see two examples here. We have the first example here. Set A is the set of all x such that x is a letter of the word smile. Okay. Now in this word smile we have the letters S, M, I, L and E. So if I were to write this set by using the listing method or the roster method, I would write it as A is equal to, it would have the letters S, M, I, L and E. Okay. These would be the elements of this set A. Going to the next set, that is set B. B is a set of all y such that y is a letter of the word miles. So B is equal to, it will have the letters of this word, that is M, I, L, E and S. Notice that in both these words there are none of the letters which are repeating inside it itself. So therefore we can write them directly M, I, L, E and S. Now you look at these two sets, set A and set B. Look at the elements of the set. We have S, M, I, L, E. That is 1, 2, 3, 4, 5. We have 5 elements here. Here 1, 2, 3, 4 and 5. So 5 elements in both the sets. So first criteria is satisfied. That is the number of elements in both the sets is the same. Now we look at each of the elements, whether the elements are the same. We have S here. We have S here also. We have M over here. M is here. We have I here. I is here. L in the set. L in the set 2. E in the set. E in the set 2. So all the elements of the first set are in the second set. Therefore we can say that the two sets are equal to each other because the number of elements in both the sets are the same and the elements in both the sets are the same, or the set elements in set A are in set B and the elements in set B are in set A. So we can write that set A is equal to set B. Now coming to the next example, example 2, where you have the set C. They have explained it as the set C contains all x such that x is equal to 4n. That is 4 is multiplying with a number n. And what is n? N belongs to capital N. What is capital N? Set of natural numbers. Therefore, this small n belongs to n. That is, this n can take the value of any natural number. Right? When we say natural number, it starts from 1. So 1, 2, 3, 4 onwards, right? And also one more condition is that this x should lie between 0 and 20. Now when I say it is 4n, the first natural number is 1. So 4 into 1 is 4. The second natural number is 2. So 4 into 2 is 8. The third natural number is 3. Therefore 4 into 3 is 12. Fourth natural number is 4. Therefore 4 into 4 is 16. Again I look at this condition here. I have to see that x lies between 0 and 20. Till now it is lying between 0 and 20. But if I put the value of n as 5, although 5 is a natural number, when I put the value of n as 5, 4 into 5 is 20 and x has to lie between 0 and 20. So can I write 20 here? If I write 20 here, x will be equal to 20, but x has to be lesser than 20. So I cannot include 20 here. So this set C will have only the elements 4, 8, 12 and 16. Let us go to the next set here. I said set D. So set D is the set of all y such that y is a multiple of 4 and y lies between 0 and 24. Now y lies between 0 and 24 means that if it is a multiple of 4, the first multiple of 4 which we know is 4. Okay, after that we have is 8, then we have is 12, then we have is 16. Okay, then we also have 20. Okay, then we also have one more multiple of 4 which is 24. Okay, so can I write 24? You see this symbol here, it is lesser than or equal to. So equal to also is considered. That means y can be equal to 24 also. Here it was x should be lesser than 20. Here y has to be lesser than or equal to 24. So that means we can take 24 also, or consider even 24 as one of the elements. So what will be the elements in this set D? It will contain the elements 4, 8, 12, 16, 20 and 24. Now if we look at the elements in set C and set D, first of all we count the elements. Here we have 4 elements in set C, but we have 6 elements in set D. Therefore, set C and set D cannot be equal. Plus, we also have to see whether the same elements are there in set C and set D. Although the criteria 1 is not fulfilled, that is, the number of elements in set C and set D are not the same, we also check the second criteria also, because we can also check whether the same elements are repeated. So let us see. Here we have element 4, here also element 4, here we have element 8, here also 8, here 12, here also 12, here 16, here also 16. But here in set D we have 2 extra elements 20 and 24 which are not present in set C. So although the definition of equal sets said that 2 sets are said to be equal if every element of the first set is in the second set and every element of the second set is in the first set, although the first condition is satisfied, that is every element of set C is in set D, the second condition, that is every element of set D should be in set C. Is that satisfied? No. Why? Because 20 and 24 are not in set C. Therefore, set C will not be equal to set D. Therefore, how do I write it? Set C is not equal to. So, equal to sign with the cut over it, which means not equal to. So, set C is not equal to set D. So, this is how we distinguish between equal and not equal sets.